era of astronomy be divided into a time before and a time after the James Webb Space Telescope? The answer seems obvious. Webb is constantly tracking down mysterious structures in the depths of space, structures that, according to our current understanding, should be impossible. This particularly refers to galaxies that formed immediately after the so-called Dark Age of the universe. These galaxies appear far too large and massive for their age, forming shortly after the Big Bang, raising serious questions about the validity of our current cosmological models. In fact, the standard model of cosmology cannot explain the existence of such early galactic heavyweights. But now, the astronomical tide may have turned. A team of experts believes they've finally cracked the mystery of these so-called universe breakers. The view of the starry night sky has always been overwhelming. Under favorable conditions, it's possible to see up to 6,000 twinkling objects with the naked eye from Earth. And since the universe is anything but stingy with its luminous attractions these days, what we're about to reveal becomes even more surprising. You see, the universe was once a place of absolute darkness. If we turn back the wheel of time to about 380,000 years after the Big Bang, we find ourselves in a cosmos filled with a hot, dense ionized plasma, completely devoid of light sources, stars, or galaxies. This was the so-called Dark Age of the universe. It wasn't until the universe cooled enough for protons and electrons to combine into neutral hydrogen atoms that light could finally travel freely. Yet, even then, no stars or galaxies existed. The universe remained dark until the birth of the first stars and galaxies, roughly 100 million years later. These early luminous objects gradually reionized the gas through their ultraviolet radiation, stripping electrons from hydrogen atoms and lighting up the cosmos once again. This period is known as the cosmic dawn and marks one of the most crucial phases in the evolution of the universe. But even today, the cosmic twilight era raises more questions than answers. Thanks to the James Webb Space Telescope, we're beginning to see that this era may have taken a very different course than previously believed. Webb, designed specifically for infrared astronomy and over 100 times more powerful than its predecessor Hubble, has a primary mission: to detect the first luminous objects and galaxies that emerged from the Dark Age. And so far, the discoveries made by this $10 billion marvel have left scientists stunned. To fully appreciate just how groundbreaking these observations are, let's recall what experts originally expected to see. According to the standard model of cosmology, astronomers anticipated spotting only tiny, baby galaxies during this early chapter of the cosmos. Why? Because there simply wasn't enough normal matter at the time to support the formation of large, mature galaxies like our Milky Way. And yet, against all expectations, Webb has revealed something astonishing: 6 galactic, premature babies, that already existed just 500 to 700 million years after the Big Bang. Despite their youth, these galaxies were already as developed as the Milky Way is today. In fact, all of the discovered objects contained more than 10 billion, and in one case, even more than 100 billion, solar masses of stars. This raised a pressing question: how is that even possible? Initially, the reaction was disbelief. Joel Leha, co-author of the study from Pennsylvania State University, admitted that his first thought was they must have made a serious mistake. However, after multiple reviews confirmed the findings, scientists were forced to confront the reality: the cosmos had revealed something that directly contradicts our most trusted theories. The implications are enormous. Could it be that the standard model of cosmology is no longer sufficient? Leha went so far as to say the discovery presents a real problem for science. Co-author Erica Nelson from the University of Colorado at Boulder echoed this sentiment, stating that our understanding of cosmology is reaching its limits, especially if even one of these galaxies turns out to be real. Why are these 6 massive galaxies so problematic for our theories? To account for their existence, the density of matter in the early universe would have had to be 2 to 5 times greater than currently estimated. Alternatively, the galaxies must have formed through mechanisms that are completely unknown to modern science. And just when scientists began grappling with these anomalies, Webb delivered even more surprises. Take the galaxy designated as JWST, JWST, for example. It existed a mere 290 million years after the Big Bang and also appears far too large and star-rich for that point in cosmic history. The same goes for the so-called red monsters, unveiled by Webb's near-infrared camera, NIRCam. These galaxies, discovered by Mengguan Xiao from the University of Geneva, date back to around 1 billion years after the Big Bang. Each is nearly as massive as the Milky Way is today, but with a shocking twist. While our galaxy forms only a few new stars per year, these red monsters boast star formation rates ranging from 795 to over 1,000 solar masses per year. Surprisingly, these red monsters may not contradict the standard model of cosmology. According to Xiao, the key lies in their extraordinary efficiency at converting gas into stars. While young galaxies typically utilize about 20% of their available gas, the red monsters seem to bypass many limiting factors, reaching conversion rates 2 to 3 times higher. How they achieve this remains an open question. But one thing is clear, early galaxies may have been 2 to 3 times more efficient at growing than previously believed. What enabled such growth is still a cosmic mystery. Yet, a new theory may provide a partial answer to the enigma of the so-called universe breakers. A team of experts has proposed an explanation for the impossible early galaxies, suggesting they may not be galaxies at all. Instead, they could represent something quite different. If you missed the 245th meeting of the American Astronomical Society, don't worry, we've got you covered. At the conference, a team led by Dale Cassis from Colby College in Waterville, Maine, unveiled findings from their analysis of the largest dataset yet on these mysterious little red dots, or LRDs. Their discovery was nothing short of astonishing. It now appears that the light emitted by many of these objects, which had puzzled experts for months, may not be of stellar origin. After re-examining the spectral data, Cassis and his colleagues found signs of extremely rapid motion, up to 1,000 km per second, within the LRDs. This motion pattern is not typical of young, massive star clusters. Instead, it points to something far more exotic, accretion disks surrounding black holes. These accretion disks, composed of gas and dust spiraling into a central black hole, are characteristic of active galactic nuclei. In other words, about 70% of the LRDs may not be galaxies at all but growing black holes. The intense light observed doesn't come from stars, but from the material being consumed by these gravitational monsters. If true, this revelation eliminates the need to explain their existence with implausibly high matter densities. It also reclassifies these cosmic puzzles as something far more familiar. However, this new explanation is not without its own mysteries. For one, why did these black holes appear in large numbers around 600 million years after the Big Bang, only to decline abruptly about 900 million years later? One theory suggests that as star formation spread, the surrounding dust and gas began to thin out. As a result, the light emitted by these objects shifted from red to blue, becoming invisible to Webb's infrared instruments. So, rather than disappearing entirely, the little red dots may have simply changed their colors. Still, this remains just a hypothesis, and the case of the LRDs has not been definitively closed. Despite all the open questions, experts remain optimistic. They emphasize that we are on the right track, and that the path forward lies in continuously comparing observational data with theoretical models. Only then can we bridge the gap between what we expect and what we actually observe in the cosmos. And speaking of perfect matches, if you've enjoyed this deep dive into the universe's greatest puzzles, don't forget to hit the like button and subscribe to our channel. Join the Space Lab community today so you never miss another cosmic revelation. We'll see you soon, under the stars. Thanks for watching Space Lab, where the universe comes to life.